Welcome everyone. Today we are going to solve partial differential equation question of Civil Services examination which was conducted on 29 September 2019. And there were question of 45 marks worth. In 2018, question were asked for 60 marks, and before that also the question were asked for 60 marks. Before I start solving the question, I must reiterate the focal area of partial differential equation in this year. First question that was asked was about formulation of partial differential equation by eliminating the arbitrary constants, and then we have to find the first order partial differential equation using method of characteristics, and we have to use second order differential equation. We have to reduce it to canonical form and then solve this. So there are only 3 questions, and now I am going to take a very important question which was asked in question number 6a. That is asking us to solve the first order quasi-linear partial differential equation by method of characteristics. X dou u by dou x plus u minus x minus y dou u by dou y is equal to x plus 2y, and x is greater than 0, y ranges from minus infinity to infinity with u is equal to 1 plus y at x is equal to 0, and this was asked for 50 marks. So this is just a mathematical approach that we have to apply. What we have learned in the method of characteristic, that is what we are going to see. So first of all, I am going to write my function, that is function of x, y, u, p and q. So I will write this as x, and dou u by dou x is represented by p plus u minus of x minus y. Dou u by dou y is represented by q, and I can bring all this equation to the left hand side. So this becomes minus of x plus 2y, and have taken the bracket. So this is the first function that we have taken, and we have to make a note here that here p is equal to dou u by dou x and q is equal to dou u by dou y. Alright, now we are given some parameters that constrains us. Well, at x is equal to 0, u is equal to 1 plus y. So here I can take the strip as x naught, that is initial x naught 0, x is s to the power 0, that is 1, that we are given over there. Now I can write y naught of s. I am going to parameterize this. So if I take this as s, so u naught of s is going to be 1 plus y, so that means s plus 1. Alright, now we also know that u naught of s and that derivative u naught dash s is equal to p naught x naught dash s plus q naught y naught dash s. Alright, so here now I am going to differentiate my u of s with respect to s itself. So this is what this becomes 1. So p naught we can write as itself p naught, and what is here, x naught is equal to 1, so its derivative is 0. So plus q naught, and what is this one, its derivative is 1. So here we get q naught is equal to 1. Now I am going to use my first equation. If I put all those to the initial conditions, so what it will become, x naught p naught plus u naught minus of x naught minus of y naught q naught minus of x naught plus 2 y naught is equal to 0. So my x naught is what, 1, and here u naught is how much, s plus 1, and x naught is 1, y naught is s. So we can see here it is again 1 plus 2 of s. So we can see here s and s get cancelled, 1 and 1 get cancelled, so this whole term vanishes. So what we are left with, we are left with p naught is equal to 2s plus 1. Alright, so we have got certain things over here. We have got our certain things, and we are going to use it later onward. So we have got some of the initial conditions. Now we are going to use the 5 equations, that is dx by dt, that is function f of p. So what is f of p? If I take derivative with respect to p, this becomes only x, and they are not further p's, so we don't need to worry about it. Now we will write our second equation, that is dy by dt. So this is f of q. So that is, we are differentiating f with respect to q, that is partially. So now let us look over here. So here only q is here, so only this term will remain. So this becomes u minus x minus of y. Alright. Now what is my du by dt? That is p times fp plus q times fq. So we can use these two things. So what we can write? We can write it as p. What is fp? X. What is q? Q is itself q. So fq is. So you can use equation number 1. Px plus qu minus x minus y till here equal to x plus 2y. So we can straight away write this as x plus 2y. Now there are other equation also, that is dp by dt and dq by dt, that I will write over here. And we are not going to use further equations because that is not required. If it is required, we will come to that. So that is dp by dt is equal to minus of fu, and dq by dt is equal to minus of fy cube fu. So we are having 5 equations. So with this we have to operate with regard to x, y and u. Okay. So here we are going to do that. So what is dx by dt? That is equal to x. So I will write it over here. So I can write my dx by x is equal to dt. So what I get over here? I can straight away write this as x is equal to, say, constant c1 e to the power t. So now I am going to use the initial conditions. What were the initial condition? X naught. What is x naught? X naught is equal to c1 e to the power at t is equal to t naught is equal to 0. So this is, so I get my c1 is equal to x naught. What is x naught? X naught is 1. So I can write it over here as 1. So I have got my x is equal to e to the power t. Okay. Now I am going to use second and third equation. But are we getting some of the terms in the realistic terms that we can operate and find this differential equation? We are seeing over here, if we divide my, say this equation 2 and this 3 and this is as 4, then if I can see a pattern, if I add equation 3 and equation 4 over here, what I will get? We will see. See here, u minus x plus minus y. So minus x and x get cancelled, and 2y minus y gave us y. So u plus y. U plus y, what it is? So we are getting it u plus y. So we can write it as dy by dt plus du by dt is going to give us y plus u, as we have added it up. So now this equation becomes what? dy plus u divided by y plus u is equal to d of t if we integrate it. So this equation becomes y plus u is equal to c2 e to the power t. Okay. So y plus u is equal to c2 e to the power t. I am again going to use the initial condition. I know my y naught. What is my y naught? Y naught is s. And what is u naught? I'll write here y naught plus u naught is equal to c2 e to the power 0. So this y naught is here s, and u naught is s plus 1. So this gives me c2. So my c2 is 2s plus 1. So I have got another thing also over here, that is y plus u is equal to 2s plus 1 t. So this is my another equation, y plus u is equal to 2s plus 1 e to the power t. So this is my one equation. I have got my x, I have got my y plus u. All I have to do is now I have to find another relationship. What is that relationship going to be? That we are going to find it out. So we can see here we are left with dy by dt is equal to u minus of x minus of y. So if I write my dy by dt is equal to u minus x minus y, So see over here, my x is e to the power t. And what is my u? I can write my u as 2s plus 1 e to the power t minus of y. Alright, and what is x? E to the power t. What is, again, it is here. So what we get over here is 2s e to the power t, e to the power t, and this one get cancelled, and we add this 2 minus y's, it becomes 2y. So we are getting a linear differential equation, that is dy by dt plus 2y is equal to 2 of s et. Okay, so this is a linear differential equation of first order. So I can write this integrating factor. This is e to the power 2 dt. So this is e to the power 2t. Okay, so we have got our integrating factor. So we can write this as y into, my integrating factor is here e to the power 2t is equal to 2 of s, integrating factor is 2t, into this et. So this becomes my 3t. So I can write it as e to the power 3t dt. So I have got some of the values over here. So I can write my y is equal to 2 of s, and I will integrate it over here, divided by 3, and here we can write e to the power 2t plus a constant. So I get y is equal to 2 of s by 3 e to the power t plus k e to the power minus of 2t. So if I put the initial condition, that is y naught, and at t is equal to 0, what is y naught? Y naught is s. So I am going to find it over here. Y naught is s is equal to 2s by 3. So e to the power 0 is what? So I have written y naught is equal to s, and 2s by 3 e to the power t value is 0, so this becomes 1, plus k e to the power minus of 0 is again 1. So I get my k is equal to s by 3. So I have got 3 equation over here, that is I can write my y is equal to how much? 2s by 3 e to the power 3 plus s by 3 e to the power minus of 2t. So I am going to use these 3 equations and find the relationship. So I am going to find it over here, the relationships. Okay, so I have got x is equal to e to the power t. I have got y plus u is equal to 2s plus 1 e to the power t, and I have got my y is equal to, I can take here s by 3 common. So I am going to take s by 3 outside from here. So I get 2 e to the power t plus e to the power minus 2t. So here I will replace e to the power t by x. So y plus u is equal to 2s plus 1 x. Okay, so I can write my 2s plus 1 is equal to y plus u divided by x. So I can further find the value of s, that is y plus u minus of x divided by 2 of x, and this value of s I am going to put into this equation. If I call this as my equation 1 and 2, I am putting the value of s from equation 1 into 2. So y s value is y plus u minus of x divided by 2x, and again it is multiplied by 3 as we can see here, and this can be written as 2x plus 1 by x square. Now I will further simplify this equation over here. So this gives me y is equal to, this is 6x in denominator, and here it is y plus u minus x, and this is 2x cube divided by x square. So this becomes 6x cube, whole becomes 6x cube. So we can write this as 6x cube y is equal to 2x cube y plus 2x cube u, alright, and minus of 2x to the power 4 plus y plus u minus x. If we take this one on this side, this becomes 4x cube y, and if you bring all of these on this side, we can write this as, so this is the solution by the method of characteristic equation. So we were given in terms of u, x and y, and answer is 4x cube y minus 2x cube u plus 2 into x to the power 4 minus 2 minus of u and plus x is equal to 0. So this question was very important because UPSC has always the habit of asking questions from method of characteristic, and it tests our understanding of differential and partial differential equation. So this question was not given in any of the textbooks. If you know your fundamentals right, you can do any question in examination under even tough situations. So now I'm going to take the second question. Okay, so this is the second question, and this question was asked in question number 7c. Here we have to reduce second order partial differential equation to canonical form and find the general solution. And it is dou square u by dou x square minus 2x dou square u by dou x dou y plus x square dou square u by dou y square is equal to dou u by dou y plus 12x, and it was asked for 20 marks. Canonical form is one of the favorite area of UPSC, and here all we need to understand is how we are good at finding partial derivatives and finding it. So this is a standard procedure for this, and we are going to solve this question. So we write over here in the standard form, that is small r minus of 2x small s plus x square t is equal to q plus 12x. If we call this as an equation 1, where r is equal to dou square u by dou x square, small s is equal to dou square u by dou x dou y, t is equal to dou square u by dou y square, p is equal to dou u by dou x, and q is equal to dou u by dou y. So here if we compare with the standard equation, that is capital R small r plus capital S small s plus t capital S small t plus function of x, y and u p q, this is 0 is equal to 0. If we compare, we can see here that capital R is 1, capital S is minus of 2 x, and capital T is x square. So if we find s square minus 4rt, we get how much? 4x square minus 4x square, that is equal to 0. So here we have got this as 0. So this is parabolic. So now we are going to find the lambda quadratic. So lambda quadratic is r lambda square plus s lambda plus t is equal to 0. So this gives me lambda square minus 2 x lambda plus x square is equal to 0. So here again the roots are repeating, that is x and x. Now I am going to write the characteristic equation, that is dy by dx plus lambda is equal to 0. So if we put the value of lambda, that is x, and find the integral of this, we get y plus x square by 2 is equal to c1, a constant. Alright, now I am going to choose a function m is equal to y plus x square by 2 and n is equal to x, such that m and n are independent function. How do we know that this is independent function? We will take the Jacobian to verify it. So if I write this in Jacobian format, that is dou mn by dou xy, then we can write them in the matrix form: dou m by dou x, dou m by dou y divided by dou n by dou x, dou n by dou y. And if you put the respective values, you can see here dou m by dou x is how much? X square. The derivative is 2x. 2x by 2 is x. And dou m by dou y is 1. Dou n by dou x is how much? 1. And dou n by dou y, we are having 0. So we find this is x into 0, 0 minus of 1. So this is not equal to 0. So we are very clear that this is m and n are chosen such that they are independent function. Now I will start finding my p, q, r and s. Here we need q, r, s and t. Obviously we have to start with p. So we have already claimed that p is equal to dou u by dou x. Now if I write this as dou u by dou m and then dou m by dou x, it can be written, and then dou u by dou n into dou n by dou x. So from here I am going to find my dou m by dou x. What is the value of dou m by dou x? X. And what is the value of dou n by dou x? Here. So here x and 1. So I can use it at x dou u by dou m plus dou u by dou n, because this value is 1. Now I will find my q. Q is dou u by dou y. Okay. So I am going to find it. So it can be written as dou u by dou m into dou m by dou y plus dou u by dou n into dou n by dou y. So what is my dou m by dou y? Dou m by dou y is 1 and dou n by dou x, dou y is 0. So this becomes 0. All we are left with dou u by dou m, because dou m by dou y value is 1. Now I will find the r. R is dou square u by dou x square. R is dou square u by dou x square. Okay. So this can be written as dou p by dou x. Now I am going to use the value of this one. So if I write this like dou by dou x, x dou u by dou m plus dou by dou x, dou u by dou n. So I will partially differentiate. I will keep dou u by dou m outside and constant and differentiate. So this is dou u by dou m plus, now I am going to keep x constant and use this as. So I can write it as dou by dou m, dou u by dou m. This can be written as dou m by dou x plus dou by dou n, dou u by dou m. This is copied, and then I can write this as dou n by dou x. I have only found till here. All that is remaining is this one. So I will find for this one also. So this can be written as how much? This can be written as dou by dou m, dou u by dou n, dou m by dou x plus dou by dou n, dou u by dou n, dou n by dou x. So this is have completed this value. Okay, so we will find the value of r. So this is dou u by dou m, and I am going to use dou m by dou x. What is the value of dou m by dou x? X. So this becomes x square. Dou square u by dou m square. What is the value of dou n by dou x? Dou n by dou x is 1. So this becomes x times dou square u by dou m n. Okay. Now what is dou m by dou x? Here we can see dou m by dou x is x. So again this is x dou square u by dou m dou n, and the value of dou n by dou x is dou n by dou x value is 1. Okay. So this is how much? Dou square u by dou m square. Now these are repeated, so I will just add it up and I will erase this one. So this becomes dou square u by dou n square. Okay. So we have got P, Q, R. Okay. And now I will find S and T. First I am finding T. So this is dou square u by dou y square. Dou square y by dou y square. So when I am finding it, this can be written as dou q by dou y. What is my q? Dou u by dou m. So I can apply over here. So this can be written dou by dou m, and here dou u by dou m. This can be written as dou m by dou y plus dou by dou n, dou u by dou m, and dou n by dou y. So what is my dou m by dou y? Dou m by dou y is 1. Okay. So this can be written as dou square u by dou m square. Now dou n by dou y, we can see here dou n by dou y is 0. Okay. So this will be nullified. Okay. We have found P, Q, R and T. Now I am remaining with only S. So I will find the S on this side and then I will proceed. I will just make note of m and n. So here m is equal to y plus x square by 2 and n is equal to x. Okay, and then I will find my s. So my s is dou square u by dou x dou y. So this can be written as dou by dou x, how much? Q. So dou q by dou x. What is the q? Q was dou u by dou m. So I can write this as dou by dou m, dou u by dou m into dou m by dou x plus dou by dou n, dou u by dou m to dou n by dou x. Okay. So dou m by dou x I can take from here. If I differentiate, this is x. So this becomes dou square u by dou m square. Now what is dou n by dou x? Dou n by dou x is 1. So we are left with dou m n. Now we have found all our values. Now our work is to put into this equation number 1. Now I am beginning with r. So this is dou u by dou m plus how much? X square dou square u by dou m square plus 2x dou square u by dou m dou n plus dou square u by dou m square. Okay, I have written the r part. Now I have to write minus of 2s. I have just found s. So if I just write over here minus of 2, so I can write this as 2x square, and here also I can write this minus of 2x. Okay, so I can write over here minus of 2x square d square dou square u by dou m square minus of 2x dou square u by dou m dou n. Alright, now I am just left with x square t. So here that is dou square u by dou m square. So here if I add it up and write as this, and on the RHS if I write q, what is my q? Q is dou u by dou m, dou u by dou m plus 12x. So I have written the equation. Now we can look it very carefully that this and this add up, and this is 2 times of it, so minus this and this can be cancelled. Similarly, we can readily see these two terms are cancelled, and LHS and RHS, dou u by dou m is cancelled. So we have got, after a lot of calculation, the equation is simplified to a very simple equation, and that is, I will write over here, dou square u by dou n square is equal to 12x. So we have reduced it to the canonical form. Now this is asked for 20 marks. We have to also find the general solution to this question. So here I will try to find the general solution. So I will write my second order partial differential equation as this, and we will bring our m and n from here. Now if I integrate it once, so I can write it as dou u by dou n, and this becomes 12x squared by 2. Why? Because n and x are same, so dou n is equal to dou x, so it could be integrated, plus some function of, say, f m, because this cannot be function, constant cannot be function of n, so it has to be of n. So we get dou u by dou n is equal to 6s square plus f of n. Now again I am integrating, so this becomes 6x cube divided by how much? 3 plus, now n, and this is constant, so we can write this as n, we are integrating, n value is x, okay, plus some function, say g of m, okay. So we have got our answer. So now u, we can write it as u is equal to 2x cube plus x, and we will plug back the value of m. M value is y plus x squared by 2 plus g is also another function. So here we have got our answer. Now this question is very pertinent because the moment what you choose n, because the roots are common, we could have taken at symmetrical also n is equal to y minus x squared by 2, or we could have taken n is equal to y also. But if you take that, it will become cumbersome. It is going to get in terms of u minus v and under root u minus v also. So it boils down to what is our choice of v. That is going to make our solution very simplified. We can see here we have got u in terms of function of f and g, and m and n are also put back. So this is the answer. Such kind of questions are not given in any of the books, standard textbooks. So if you know your concept very well, and here our main target is to focus on the conceptual as well as understanding and methodical part of the questions and the underlying principle behind it. So if we have the robust understanding of our concept, no matter how difficult or difficult question it may seem, we will be in a very good position to solve those questions as we have done right now. So partial differential equation was asked for 45 marks also, but these marks are very, very critical, and I am going to take the last question, which is merely just to find the formulation of PDE. The third question is, this question was asked in question number 5a. This was a compulsory question. This is an easy question, asked for 10 marks only. So we have to form a partial differential equation of family of surfaces psi x squared plus y squared plus 2z squared comma y squared minus 2zx is equal to 0. So we are going to find solution to this question. So we can write this as psi of u and v, that is equal to 0, and I call this equation 1. So u is x squared plus y squared plus 2z square, and v is y square minus 2z of x. So now I am going to write two other equations, that is I am going to differentiate equation 1 partially with respect to x and y. Okay, first I am going to write with respect to x. So this I can write as first equation. This can be written as dou psi by dou u into dou u by dou x into dou x by dou x plus dou u by dou z into dou z by dou x. Alright, and we have another also, that is d psi by dou v. Again we will write for v. This is dou v by dou x into dou x by dou x plus dou v by dou z and dou z by dou x equal to 0. So we have written for this equation. Again I will differentiate equation 1 partially with respect to y. Suppose I call this as equation 2, and now I can write it like similar fashion: dou psi by dou u, this is dou u by how much? Dou y, and this becomes dou y by dou y plus dou u by dou z and dou z by dou y, okay, plus dou psi by dou v. This can be written as dv by dy, dou v by dou y, not and this can be written as dou y by dou x plus dou v by dou z, and this is dou v by dou z by dou y is equal to 0. I call it as equation 3. Now I will put some of the values. Okay, so for that I will first find my dou u by dou z. So dou u by dou z is how much? We can write from here. This becomes 4z. Okay. Similarly, what is mine? Dou v by dou z. Dou v by dou z is here. So this is again minus 2x. Okay. Similarly, I am going to find my other things also. So here I am going to divide equation 1 and 2. For that, first I will put the values. So I write it as dou psi by dou u. Okay, and dou u by dou x value I can write. What is the value of dou u by dou x? It is 2x plus, now dou x by dou x is 1. So now I will write the value of what? Dou u by dou z. Dou u by dou z is what? 4z. And we know that dou z by dou x is standard form. We can write it as p, and for q, dou z by dou y. So I can write this as p plus, if I set this on the opposite side, so this becomes minus of dou psi by dou v. Okay, so what is mine? dv by dx, dv by dx can be written as minus of how much? 2z. Okay, and again dou z by dou x is how much? p, and dv by dz can also be found out. So dou v by dz is how much? Minus of 2x. Okay. Similarly, for this equation, I will write dou psi by dou u. Okay. What is my dou u by dou y? 2y plus dou z by dou y can be written as q. And what is dou u by dou z? Plus 4z. Okay. Similarly, I will set this on this side. So this becomes dou psi by dou v. This can be written as, what is the value of dou v by dou y? 2y plus this is again q. So what is the value of dou v by dou z? Dou v by dou z is minus of 2 of x. Okay. So if we just divide these equations, we are going to cancel out some of the terms. So I will first of all take 2 outside all of this. So I can write this as x plus 2zp is equal to z plus px, alright, divided by this one. So I will write this as y plus 2zq divided by y, again because there is a minus sign, so I will write it as qx minus y. Okay, now I will find the terms. This is x square cube, okay, x square cube minus of xy minus of xy plus 2z x p cube and 2z py, and on this side this is yz plus p xy plus 2z square cube plus 2p cube xz. So 2p xz here will be cancelled, and if I will bring all the terms on one side, okay, so I will get pxy on this side I am bringing, so this becomes my 2pxz, and I bring the q term here. Q is how much? Q is 2z square minus, if I bring this side over here, so this becomes x square. And what is left? We are left with yz on this side, xy. So if I bring all this side also, so I can write it as plus xy is equal to 0. So I will rearrange, I will write p and y, x is common, so I will write y plus 2z q 2z square minus x square, and I can send this side, so this can be written as, so what is common here? Y is common here, so I can write it as x plus z. So this is the standard form of writing auxiliary equation, that is pp plus qq is equal to r. So this is our answer, px into y plus 2z plus q 2z square minus x square is equal to minus sign of y x plus z. So such kind of question is normally asked in 10 markers. So with this we end our lecture series on partial differential equation to solution of Civil Services Mathematics Optional 2019. If you have any doubt with regard to characteristic method or canonical form reduction, you can ask questions that are also asked previously which you find difficult to solve. And if you want me to make a video on these topics also, you can comment in the comment section and you can interact with us. So thank you for watching. Please like, share and subscribe.